4.6, conjugate zero. So like I indicated before, remember when you're solving the quadratic, you've got that plus or minus, or anytime you're taking a square root. So when I have a I in one of my zeros, they're going to come in pairs because of the plus or minus. So that's your conjugate zero theorem, means that if you have, so they're going to give you only one of the values, then you have the opposite values. So same thing with i's and radicals, come in pairs. That's basically, this is your technical definition of it, but really what it is saying is that I and square root come in pairs. Okay, so you have a plus and a minus. So find a polynomial having zeros, -4, and I. So they're only giving you one of the i's, which means you have to find the other one. So you say, okay, there is a negative I. You've got a plus and a minus. And then find the polynomial. So remember when we did the zeros, those are your factors. Okay, so to find the polynomial with these values, here is what you are going to do. You are going to go x minus, and then I'm just going to put here c because I think that's the definition we use here, meaning your factor. I'll just put in parentheses 0. Okay, so they give you the zeros, you're going to go x minus that 0. So I've got x minus -4. I've got x minus I, and I have x minus -I. And I'm going to multiply it out. Okay, this should be a third degree because I have 3 factors. Okay, so however many factors you have, that's going to be the degree polynomial that you have. So you're going to take these and multiply them out. So here I would make this a plus, and this one as well. You can multiply in any order you'd like, but when they come in pairs like that, it's easy to do that because you know that your middle terms will cancel out. So I would do the x minus I, x plus I first. And you're just going to FOIL these two out. So you've got x times x squared, x times I, that's a positive, xi or ix, it would be ix. But then a negative xi, and then negative I times positive I will give you a negative I squared. And do we remember what I squared is? You said 1?
Yeah.
Close? -1, good, -1. So then this would be, take this, cross it out, -1. These guys cancel out. So then this is x squared minus -1. So this becomes x squared plus 1. Yeah.
So even though there's a negative number in front of the I squared, it's still going to be a -1. It doesn't cancel out.
Well, it does here. So I wrote it twice here. So it stays, you can do it all at once if you'd like, but it's x squared minus -1. So then it does turn into plus. So it goes like this. So then we have x squared plus 1. Then take that x plus 4 and bring it down. Multiply that out. So then you've got x times x squared. It's going to give you an x cubed. X times 1, 1x. 4 times x squared, 4x squared. 4 times 1, 4. So we have the polynomial. We just put it in order. So we say p of x, the polynomial of our function x, is x cubed plus 4x squared plus x plus 4. So it's pretty easy as far as you're just multiplying. Okay, but it does get a little complicated, especially when you have things like 2 plus I radical 6 or something like that. All right, so let's look at this next example. So this one gets a little more complicated because we have zeros of 1, 5, 3 plus I, and what's the other one? 3 minus I. Good. All right, so set this up as x minus your 0. So you've got x minus 1, x minus 5. Here is how you're going to tackle these. X minus, inside parentheses, 3 plus I. Okay, another parentheses, double parentheses there. X minus 3 minus I. Okay, and we'll get back to that. Let's first multiply out x minus 1, x minus 5. Okay, so here you have x times x, x squared. X times negative 5, negative 5x. Negative 1 times x, negative 1x, negative x. Negative 1 times negative 5, positive 5. Really be careful with your multiplication here because one little misstep messes up the whole problem. That's why I'm trying to go a little slower with my multiplication. And I still make mistakes. This is why I'm having you guys submit your written work, the test, which we'll go over the last 5 minutes. So then this becomes, let's see, x squared minus 6x plus 5. So I'm going to put that in parentheses, and I'm going to deal with this. Okay, so what I want to do here is I want to take this minus and distribute it. Okay, first, so this is like a negative 1 here. So this just becomes a minus 3 and a minus I. And then this will become minus 3 plus I. So really, you can just put it up like this. The only thing is if it started with a negative in front of here, it does kind of change things a bit. So that's why I like to take this extra step here and distribute the negative sign. Okay, then you have to multiply this out, which means you're distributing a 3 by 3. So if you wanted to do the box, you can do that, or I just do the long distribution and try to line things up as I go. So what I mean by that is this. I'm going to take the x. So x times x is going to be x squared. Then x times negative 3, negative 3x. And then x times I, positive xi. Okay, then I'm going to go to the negative 3. So let me color code these for you guys. Okay, so then the negative 3 times each term. So negative 3 times x would be negative 3x. Then a negative 3 times negative 3, that's not lining up with anything. So I'm going to come over here, positive 9. And then negative 3 times I is negative 3i. Okay, then let's go orange here. So then I times everything, so negative I times x. And put that right here, that's going to be a negative xi. Negative I times negative 3 would be a positive 3i. And then negative I times positive I, negative I squared. Okay, then I can draw my line and add everything. It's kind of all lined up. So I've got this x squared that can come down. Negative 3x gives me negative 6x. Positive xi, negative xi, those are going to cancel out. I have a positive 9 coming down. These guys are going to cancel out too. So notice things with your eyes are canceling out. Okay, then negative I squared, that's negative 1, right? So negative 1 gives you a plus 1. So then this is x squared minus 6x plus 10. Now, so they're long problems. Now you pull this down, multiply these guys out. So you've got x squared minus 6x plus 5. And now we're going to do this distribution again. All right, so you've got x squared times x squared. That's going to be an x to the 4th. Then x squared times negative 6x, that's going to be a negative 6x cubed. Then x squared times 10, that's going to be a positive 10 x squared. All right, then we're going to take the negative 6, distribute this. So negative 6 times x squared. That's a negative 6x squared. Nope, negative 6x times x squared, negative 6x cubed. Okay, then negative 6x times negative 6x, that's going to be positive 36, 6 times 6, and then x times x squared. Then negative 6x times positive 10, negative 60x. Okay, then 5. So 5 times x squared, it's going to be a positive 5, x squared. 5 times negative 6x is a negative 30x. 5 times 10, positive 50. And then let's add them all together. So we have x to the 4th. You have negative 6 minus 6, that's negative 12 x cubed. See what we've got here. So 10 plus 36 is 46, plus 5 is 51. X squared, it's going to be a negative 90x plus 50. And that's our function. Long problem. And it can be even longer. I have one more example here where it's longer. So these ones are a lot. Now, it's really hard to check your work with this. That's why you have to be careful going through with the multiplication. You can check your work 2 ways. So first thing I'm going to do, you can graph it and make sure your real zeros show up. That will be helpful. But your imaginary zeros you're not going to see. So you could work the problem backwards. Takes a lot of time again, right? So find the zeros and factor them out. So those are really your 2 options for checking. You can check, but it takes a long time. I would just do a quick check and put the problem in your graph and make sure you can see the real zeros. Okay, so if I put this in, let's see, x to the 4th minus 12x cubed plus 51x squared minus 90x plus 50. So we should be able to see 1 and 5. 1, 2, 3, 4. Okay, so if we can see those 2 zeros and you don't see another random 0 on there, then you should be okay. That's a good way to just do a quick check instead of working the entire problem backwards. Any questions on this? Yeah. The negative 1. Okay, I squared is negative 1. So what I'm doing is I'm just taking this I squared here. So it was minus I squared. So I just take the I squared and replace it with a negative 1. So it's minus negative 1, which turned into a positive 1 because of the double negative there. So if it says plus I squared, then it's just minus 1. If it's minus I squared, it's minus negative 1, so it turns into plus 1. It's almost always minus because you got the negative I and the positive I. So it's almost always going to turn into a positive 1 because of the double negative at the end. To show what? Yes. It's not showing the same on your calculator. Look at your y equals and make sure you put the problem in correctly. I can take a look at it in a little bit. All right, so yeah, I want to show you guys this. So this is how it can get a little more complicated. But this only has how many zeros? 3 zeros. So it's going to have 3 zeros. So it doesn't have 4. It's not as long as one before, but it does have this extra requirement where P of 1 equals 8. Okay, so we have to see how we do that problem. And I have to see if I can remember how to do it. Okay, so what's my other 0 that I'm missing? 2 minus x. Okay, so I set this up. I've got x minus 3, then x minus 2 plus I, x minus 2 minus I. Okay, so because I don't have another x minus and a real number, we'll do the i's first. So this is going to distribute and become x minus 2 minus I. this is going to become x minus 2 plus I. Okay, so let's go ahead and distribute this. So we will start here. So we've got x times x. I'm just going to go over here. I'm going to write it in one big list this time for this one. So you've got x squared. Then x times negative 2 will be a negative 2x. Then x times I will be a positive xi. All right, then my next row, I've got negative 2 times x, that's a negative 2x. Then negative 2 times negative 2 gives me a positive 4. Negative 2 times positive I will be a negative 2i. All right, then negative I times x, negative xi. Negative I times negative 2 will give me a positive 2i. And then negative I times positive I gives me a negative I squared, which I could just go ahead and immediately just take that and make that a negative 1. So negative, negative 1, which becomes positive 1. Okay, so then let's combine like terms. So I've got an x squared. I've got negative 2x, negative 2x. It's my only term, which is the x. That's going to be negative 4x. I've got positive xi, negative xi, which means these guys are going to cancel each other out. I also have this negative 2i and this positive 2i. These guys will cancel each other out. And then I have 4 plus 1, which will give me a plus 5. All right. Then I am going to multiply this with the x minus 3. And then this time, because I don't have any of the i's or anything, now I can line this one in rows. Okay, so we've got x times x squared, that's going to be an x cubed. Then x times negative 4x gives us a negative 4, x squared. Then x times 5 gives us a positive 5x. Okay, then negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x, positive 12x. Negative 3 times positive 5 is going to be a negative 15. Combine these. We've got, let's see, x cubed minus 12 x squared plus, why did I do 12? You guys didn't even say anything. I multiplied them because I was so used to doing the multiplication. What should that be? 7. Yeah. And then this should be a 17x minus 15. Does that look good? Okay. All right, so let me check real quick. I just need to see the 3, right? So let me check. That might not work because we're not done with the equation, but let's see. So we've got x cubed minus 7x squared plus 17x minus 15. All right, good. We go through the 3, so we know we're good on to go there. Now, the requirement. So, remember, this is a polynomial equation, so p of x equals this polynomial. So this has a leading coefficient of 1. So your leading coefficient in a function is always going to be a. So you might see some problems that say assume a equals 1. Okay, that is your leading coefficient. So this one is telling us that our leading coefficient might not, I know that's not spelled right now. Our leading coefficient might not be 1. It might be something different here. So what you're going to do is you're going to take this You're going to put this in parentheses. You need to find a new leading coefficient, okay, because it's not 1. And the way we find that is we use the P of 1 equals 8, which means the x is 1, the y is 8. So the input is 1, meaning I put 1 in for all of these x's. The output is 8. Okay, so that means that this becomes 8. I have the a, and then all of these x's become a 1. So I'm trying to find a in this case. Okay, so we go through and we try and solve this. We've got, let's see, 1 cubed is 1. 7 times 1 squared, that's negative 7, plus 17, minus 15. It may very well be 1 in this case. 1 minus 7 is 1 minus 7 plus 17 minus 15. Negative 4. Okay, so we get negative 4 in this case. So we have a times negative 4 equals 8. So we solve for a, divide by negative 4. Okay, that gives us negative 2. So we have an a value of negative 2. So now what we're going to do with that is we're going to take that negative 2 and we're going to go back up here to this line. And we're going to plug that a in, and then we're going to distribute it. Okay, so this is going to become negative 2 times x cubed minus 7x squared plus 17x minus 15. And then we're going to distribute that out. So this is negative 2x cubed plus 14 x squared minus 34 x plus 30. Now we are done. So that's about the longest that the problem can get. I didn't put one like this on your test, but I know there's like 2 on your homework like this as well. The ones on your test are just leading coefficients of 1. Okay, so are there practice problems here? So I'll do this practice problem on a recording for you guys for these ones as well.